Hey there, welcome to TechX Bytes. Today, we're taking our first steps into Python coding, and by the end, you'll be ready to start building your own Python programs. So without further ado, let's dive right in. All right, so the very first thing we're going to learn is how to make Python display something on the screen. We do this using a special word called print. After print, we need to add a pair of parentheses. These parentheses are where we'll put the information we want Python to show. Now, inside the parentheses, we'll put what we want to display. Let's start with the classic greeting, "Hello, world." Make sure to enclose it in double quotes. Okay, to actually run this Python program and see our "Hello, world" message, we need to use the terminal. You'll want to type Python 3 hello, py, and then hit enter. This command tells your computer to use the Python 3 interpreter to run the file named hello, py. And just like that, you should see "Hello, world" pop up in the terminal. Pretty cool, right? Now, as we start writing more code, we'll want to add notes to ourselves, and that's where comments come in. So, imagine you're writing a program and you want to leave a little note for yourself. For a single line note, we can use the hash symbol. Anything you write after the hash symbol on the same line will be ignored by Python. It's just for us humans to read. What if you want to write a longer comment that spans multiple lines? For that, we can use triple single quotes. Let's add the opening triple single quotes. Now you can write your comment across several lines. To tell Python where the multi-line comment ends, you need to add another set of triple single quotes. All right, let's run this comments py file using the command python 3 comments, py in the terminal. Go ahead and try it. You'll notice that nothing actually gets printed out. That's because all we had in that file were comments, and as we just learned, Python doesn't pay any attention to them. They're purely for us humans to read. Now, something that Python does pay very close attention to is how your code is formatted, especially when it comes to spaces and indentation. In Python, the way you structure your code with spaces, especially at the beginning of lines, is very important. Let's introduce an if statement. The if keyword is used to check if a condition is true. Here, we're simply checking if true is true, followed by a colon. Now, the line of code that should run if the condition in the if statement is true needs to be indented. You can use 4 spaces for indentation. Here, we're adding a print statement that says indents matter. This indentation tells Python that this print statement belongs to the if block. Let's see this in action. Okay, let's run the indent py file with the command python 3 indent py. If the indentation in the code is correct, you should see the message indents matter printed in the terminal. This shows that Python recognized that the print function belongs inside the if block because it's indented. Mess up the indentation and you'll see Python complain. Here's where we give things names, like variables. Think of a variable as a label you can stick onto a value so you can refer to it later. In Python, you create a variable simply by choosing a name and then using the equals sign to assign a value to it. For example, here we're creating a variable named x and assigning the number 5 to it. Then let's create another variable called name and assign the text Alice to it. Remember to put text values inside double quotes. We can then use these variable names to access the values they hold. Let's use an f-string to print the values of both x and name. Go ahead and run the variables py file using python 3 variables py. You should see in the output that the value of x is 5 and the value of name is Alice. This confirms that we've successfully stored these values in our variables. Now, it's important to know that these variables can hold different kinds of information, and in programming, we call these kinds of information data types. Let's explore some of the fundamental data types in Python. Python deals with different kinds of data, and the first type we'll look at is the integer. Integers, or int for short, are simply whole numbers, numbers without any decimal points. So, in this example, we're assigning the value 5 to the variable x. To see what type of data x is holding, we can use the type function. Let's run this and see what Python tells us. Okay, run python 3 types int pi in your terminal, you should see in the output that the value of x is 5 and its type is class int, which stands for integer. Now, what if we want to work with numbers that have decimal points? That's where floats come in. Floating point numbers, or float for short, are numbers that have a decimal point. They're used to represent numbers that aren't whole numbers. Let's assign the value 3.14 to a variable named pi. Let's use the type function again to see what Python thinks about this. Go ahead and run Python 3 types float, pi. You'll see in the output that the value of pi is 3.14 and its type is class float. Just as we expected, Python identifies 3.14 as a float, so we've seen integers and floats for numbers. What about text? Well, that's where strings come in. Strings, or str, are used to represent sequences of characters, basically just text. Let's assign the text Bob to a variable named name. Remember to enclose text in either single quote or double quote. Let's check its type using the type function. Run Python 3 types str, pi, and you should see in the output that the value of name is Bob and its type is class str. So, Bob is indeed a string. We've covered integers, floats, and strings. There's one more fundamental data type we should know about: booleans. Booleans, or bool, represent truth values. They can only be one of two values, either true or false. Notice the capital T and F. Let's assign the Boolean value true to a variable named isActive. Let's see what its type is using the type function. Run Python 3 types bool, pi, and you'll get in the output that the value of isActive is true and its type is class bool. So, true is a Boolean value. Now that we know about different data types, sometimes we might need to change a value from one type to another. This is called typecasting. Let's say you have a number, but it's stored as a string. For example, here we have xstr, which holds the text 10. If you want to perform mathematical operations on it, you'll need to convert it to an integer. You can do this using the int function. We pass the string 10 to int and store the result in the variable y. Let's run this and see the types of both xstr and y. Run Python 3 casting int, pi. You'll see in the output that the value of xstr is 10 and its type is string, but the value of y is 10 and its type is integer. So we successfully converted the string to an integer. We can also do the reverse convert a number to a string. Let's take a look at that. Sometimes you might have a number, like 123 stored in the variable num, and you need to treat it as text. You can convert it to a string using the str function. Here, we're taking the integer num and converting it to a string, storing the result in numstr. This can be useful when you want to combine numbers with other text. Let's run this and check the types. Run Python 3 casting str, pi. The output will show that the value of num is 123 and its type is integer, while the value of numstr is 123 and its type is string. So we've seen how to convert between integers and strings. We already used the type function a few times to check the data type of a variable. Let's focus on that a bit more. Let's say we have a variable x, assign the value 10. As we've seen, the type function is super handy when you want to know what kind of data a variable is currently holding. You just put the variable name inside the parentheses, and Python will tell you its type. Let's run this and see what type x gives us. Run Python 3 check type, pi. The output will be class int, which, as we know, means that x is an integer. Knowing the type of your variables is important, especially when you start doing operations with them. Speaking of interacting with your program, what if you want to get some input directly from the person running the program? That's where the input function comes in. The input function is a way for your program to ask the user for some information. When Python encounters the input function, it will display whatever message you put inside the parentheses, in this case, "What's your name?" And then it will wait for the user to type something and press enter. Whatever the user types is then returned by the input function as a string, which we can then store in a variable. Here, we're storing the user's input in the variable name. And then we're using an F string to print a personalized greeting. Let's try running this. Run Python 3 input, pi. You'll see the prompt, "What's your name?" appear in the terminal. Go ahead and type your name and press enter. You should then see the program greet you with "Hello, your name?" Remember that the input function always returns a string, even if the user types in a number. Now that we know how to get input, let's look at how we can make our output look a bit nicer using F strings. Let's start with a variable name assigned to Alice. And let's add another variable age assigned to 30. We've already seen a little bit of F strings. They're a really convenient way to embed variables directly inside strings. You start a string with an F before the opening quote, and then inside the string, you can put any variable name inside curly braces. Python will then replace those braces with the actual value of the variable. Here, we're using an F string to create a sentence that includes the values of name and age. Let's run this and see the formatted output. Run Python 3 formatted output, pi. You should see the nicely formatted output, "Hello, Alice, you are 30 years old." This makes it really easy to create dynamic messages in your programs. Now that we can work with variables and format our output, let's talk about doing some calculations with numbers using arithmetic operators. Python can do all the basic math you'd expect. For addition, we use the plus symbol. Here, we're calculating the sum of 5 and 3 and storing the result in the variable SumResult. Then, we're printing out the result. For subtraction, we use the minus symbol. Here, we're finding the difference between 10 and 4 and storing that in difference. Let's print out this result as well. Let's see these operators in action. Run Python 3 arithmetic add sub, pi. You should see in the output that the sum is 8 and the difference is 6. So, addition and subtraction work just as you'd expect. Now, let's look at multiplication and division. For multiplication in Python, we use the asterisk symbol. Here, we're calculating the product of 5 and 3 and storing it in product. Let's print the product. For division, we use the /. Here, we're dividing 10 by 2 and storing the result in division. It's important to note that in Python 3, division using the /, always results in a floating point number, even if the result is a whole number. Let's run this and see the output. Run Python 3 arithmetic muldiv, pi. You'll see in the output that the product is 15 and the division result is 5. Notice that even though 10 divided by 2 is a whole number, the result is shown as 5, which is a float. Now that we know how to do basic arithmetic, let's look at assignment operators, which are a handy way to modify the values of variables. We've already used the most basic assignment operator, which is the equals sign. It simply assigns the value on the right to the variable on the left. Let's assign the value 5 to the variable x. Let's run this to confirm. Run Python 3 assignment simple, pi. You should see in the output that the value of x is 5. Now, Python also provides shorthand assignment operators that combine an arithmetic operation with assignment. Let's look at the add and assign operator. Let's start with the variable x, assign the value 5. The add and assign operator, written as plus equals, is a shortcut. Instead of writing x equals x plus 3, you can simply write x plus equals 3. This does the same thing. It takes the current value of x, adds 3 to it, and then updates the value of x with the result. Let's run this and see the effect. Run Python 3 assignment add, pi. You'll see in the output that the value of x is now 8. This is because we started with x as 5, and then we added 3 to it using the plus equals operator. Similarly, there's a subtract and assign operator. Let's start with the variable x, assign the value 10. Just like plus equals, the subtract and assign operator, written as minus equals, is a shorthand for subtracting a value from a variable and then assigning the result back to that variable. So, x equals 2 is the same as writing x equals x, 2. Let's run this and see the result. Run Python 3 assignment sub, py. The output will show that the value of x is 8 because we started with x as 10 and then subtracted 2 from it using the minus equals operator. Besides assigning values and doing arithmetic, we often need to compare values in our programs. That's where comparison operators come in. The equal to operator, written as double equals, checks if two values are the same. It will return true if they are equal and false otherwise. Here, we're checking if 5 is equal to 5, and we're storing the result in the variable is equal. Let's run this. Run Python 3 comparison equal, py. You should see in the output that the question is 5 equal to 5 is answered with true. Now, let's look at another comparison operator, greater than. The greater than operator, which is just the greater than symbol, checks if the value on the left is greater than the value on the right. It returns true if it is and false otherwise. In this example, we're checking if 5 is greater than 3 and the result is stored in is greater. Let's run this. Run Python 3 comparison greater, py. The output will show that the question, is 5 greater than 3, is answered with true because 5 is indeed greater than 3. Comparison operators are often used in conjunction with logical operators to make more complex decisions in your code. Let's take a look at logical operators. The AND operator is a logical operator that combines two or more conditions. Let's start with the condition 5 greater than 3. Now let's add the AND operator. And let's add the second condition, 2 less than 4. The AND operator returns true only if all the conditions are true. If even one condition is false, then the entire expression becomes false. Let's print the result. Run Python 3 logical and py. You'll see in the output that the result of 5 greater than 3 and 2 less than 4 is true. Now, let's look at another logical operator called OR. The OR operator is another logical operator that combines conditions. Let's start with the condition 5 greater than 3. Now let's add the OR operator. And let's add the second condition, 2 greater than 4. The OR operator returns true if at least one asterisk of the conditions is true. It only returns false if all the conditions are false. Let's print the result. Run Python 3 logical ORPY. The output will show that the result of 5 greater than 3 or 2 greater than 4 is true. Logical operators like AND, OR are crucial for controlling the flow of your program, allowing it to make decisions based on different conditions. Let's see how we can use these with if and else statements. The if statement is a fundamental part of programming that allows your program to make decisions. Let's start with a variable age set to 20. The if keyword is used to start an if statement. It's followed by a condition. Here, we're checking if the value of age is greater than or equal to 18, followed by a colon. If this condition is true, then the code inside the if block, which is indented, will be executed. In this case, it will print you are eligible to vote. Let's run this. Run Python 3 if statement, py. Since the age is 20, which is greater than or equal to 18, the condition is true and you should see you are eligible to vote. Printed in the terminal. But what if the condition is false? That's where the else statement comes in. Let's change the age to 15. We still have our if statement checking if age is greater than or equal to 18. The else keyword provides an alternative block of code to execute if the condition in the if statement is false. It's followed by a colon. The code inside the else block, which is also indented, will be executed if the if condition is false. Here, it will print "You are not eligible to vote yet." Let's run this and see. Run Python 3 if-else statement, pi. With the age set to 15, the condition in the if statement is false, so the code inside the else block is executed, and you'll see "You are not eligible to vote yet" in the terminal. So if and else allow your program to take different paths depending on whether a condition is true or false. Sometimes you might want to repeat a certain block of code multiple times. That's where loops come in. Let's start with the while loop. A while loop is used to repeatedly execute a block of code as long as a certain condition remains true. Let's start with a variable count set to 1. The while keyword starts a while loop. It's followed by a condition. Here, the loop will continue as long as count is less than or equal to 3, followed by a colon. Inside the loop, which is indented, we first print the current value of count, and then we increment count by 1 using count plus equals 1. This process will repeat until count becomes 4, at which point the condition count less than or equal to 3 will be false, and the loop will stop. Let's run this and see the output. Run Python 3 while loop basic, pi. You should see in the output count is 1, then count is 2, and finally count is 3, each on a new line. This shows how the while loop repeated the code block until the condition was no longer true. Another very common type of loop in Python is the for loop. The for loop in Python is often used to iterate over a sequence of items. The for keyword starts a for loop. Next, we specify a variable that will hold the current item in the sequence during each iteration. Let's use I. The in keyword indicates that we're going to iterate over a sequence. Here, we're using the range3 function, which creates a sequence of numbers starting from 0 up to, but not including 3. So, it will generate the numbers 0, 1, and 2. The line ends with a colon. The for loop then goes through each of these numbers, one at a time, and for each number it assigns it to the variable I and then executes the code inside the loop, which is indented. In this case, it will print loop number followed by the current value of I. Let's run this and see what happens. Run Python 3 for loop range, pi. You'll see in the output loop number 0, then loop number 1, and finally loop number 2, each on a new line. The for loop provides a clean and easy way to repeat a block of code a specific number of times or for each item in a sequence. Now, as your programs get more complex, you'll often want to organize your code into reusable blocks. That's where functions come in. Functions are reusable blocks of code that perform a specific task. You define a function using the def keyword, followed by the name you want to give to your function. Let's call it greet. Then parentheses, which can contain parameters, which are inputs to the function. Our greet function will take one parameter, name. The line ends with a colon. The code that belongs to the function is indented below the def line. The return statement is used to send a value back from the function. In this example, our greet function creates a greeting message using an f string and then returns that message. Now that we've defined our function, we need to actually use it, which is called calling the function. To use the function we just defined, we simply write its name followed by parentheses. If the function expects any arguments, like our greet function expects a name, we put those values inside the parentheses. Here, we're calling the greet function with the argument Alice. The function will then execute its code, and in this case, it will return the string, "Hello, Alice." We're then storing this returned value in the variable message. And finally, let's print the value stored in the message variable. Let's run this and see our function in action. Run Python 3 function simple, pi. You should see "Hello, Alice" printed in the terminal. This shows that we successfully defined and called our greet function, and it returned the expected greeting. Functions are incredibly useful for organizing your code and making it more reusable. And that's it for our Python Basics tutorial. You've covered a lot of ground today. You've learned how to print, get input, use variables, understand data types like integers, floats, strings, and booleans. You've also learned about typecasting, formatting output, basic arithmetic and assignment operators, comparison and logical operators, and how to control the flow of your program with if and else statements as well as while and for loops. This is just the beginning of your Python journey, so keep practicing, keep experimenting, and don't hesitate to explore what we can learn next. Happy coding!